Okay, yeah, guys. So let's start with this session, and uh, for people who have joined new, I see some new names here. My name is Abhishek, so I take this class. No, Padmakar, I muted everyone, so I can't hear you. If there is anything urgent, you can unmute yourself and we can discuss. Otherwise, let's continue with this call. Okay, thanks a lot. So this is a course content which we will be covering today. We'll be discussing about inheritance and then super and final keyword. Super and final keywords. So this is a session 4. Okay, so let's move on. So if you remember the first class which we had, I mean there are a number of basic pillars of object-oriented programming which we discussed. Encapsulation was one of them, abstraction, then inheritance, then polymorphism, and I think these were the only ones. So if you remember polymorphism, which essentially meant taking many shapes, and as I discussed at that time, I mean a method can take many uh, shapes in the sense that you can write a method and for a different class there can be different requirement for a different combination there can be different requirement, say, right, many interfaces. So I mean, there can be different methods, and that is a form of polymorphism which we discussed in the last class, which was method overloading. Okay, now there is another type which is method overriding. So that essentially means, and that is just a step ahead. So it's taking I mean it's using inheritance. So when you use inheritance, what happens? I mean, as we discussed before, so inheritance means that you are you have some base set of attributes, okay, and you're using them to create a blueprint, okay, and then you inherit all those attributes and maybe add some additional attributes. So the example which we discussed last time was, and it is just an example, plain example. So the example which we discussed last time was, like, say there's an employee class, right? So there's an employee class and it has employee ID, employee name, first name, last name as the attributes. Now there is another class such as CEO. Now CEO is also an employee, but it has certain additional attributes for itself, such as privilege status. Maybe there is a separate class perks which has to be included here. So what do? So the thing which you do is that you include, you extend employees. So CEO extends employees, which means CEO inherits all the attributes which are there for employee, and in addition to it, it has some additional attributes. So in this way, what happens is that most of the attributes you put in a common place, you try to reuse the common piece of code, and only additional information is kept in a different place. Now, if you do in this way, then a question might arise, like, say I have some implementation in my in my base class, such as employee, and basis class is just my way of saying it. The standard terminology is parent class. So employee is a parent class and CEO is a child class. Okay, so there can be a scenario where you have a method like, say, salary. Now salary is a method which is calculated in one way for the employees, right, and is calculated in a different way for the CEO. So the same salary method has to be overridden in the CEO class, right? So this means that the salary method has different implementation for the employee class and a different implementation for the CEO class. So since this difference is there, someone is not on mute. Can they go on mute, please? Just a second. Okay. So the salary method as such is there in the employee class, and it's there in the CEO class as well. So we have overridden the things. So we have provided different implementation because whatever was the base implementation was not suitable. Okay. Now this is one way. Guys who are joining new, please mute yourself because we are in the middle of the class. We just started, but it's better that you mute yourself. Now, the C, so this is one scenario. The second scenario is, say, I mean, the way the salary is calculated is same for CU. Now this is another requirement. Is same for a CU, but there are some additional changes. So what do? When you have your method, you do your own calculation, and after that uh, you call the base class. So in this way you can uh, have the common code, like say salary computation, in one place inside employee, and whatever is additional can only be there in the CO class. Okay, so this is how it can be, and this is an example of method overriding, which is a different form of polymorphism. So on high level you can understand polymorphism has two ways, has two types. One is method overloading, okay, and one is method overriding. Method overloading is what we discussed in the last class, and method overriding is what we discussed right now. Okay, so there are two forms in which a class can take many shapes. One is the method itself can be having different parameters or different types of parameters. Okay, the return type as such doesn't have any say, has any effect on the polymorphism. So if you just have the same method signature everywhere, like say area, you pass int a comma int b, and instead of um long, which was a return type, you pass string. That is not polymorphism. Compiler is going to give you runtime error. Okay, so we'll discuss on that slowly, because we like below that we have another topic for method overriding. But since this is closely related to inheritance, I thought it's better to give a taste of it upfront. Okay, okay then. So class can be defined as a subclass of another class. The subclass inherits all data attributes of its superclass. Subclass inherits all methods of its superclass. The subclass inherits all associations of its superclass. And in the example which we discussed, CEO is the subclass, okay, and employee is the superclass. Okay, the subclass can add new functionality, use inherited functionality, override inherited functionality. Now, add new functionalities, it's a class, right? So anything you can add new. I mean, it doesn't stop you. Use inherited functionality. What is there in the superclass, as we discussed? You can go ahead and use it. I mean, that's the basic behind this particular concept, inheritance, reuse. Third is override, and this is the method overriding concept which we're discussing right now. So method overriding is what inheritance also gives in Java, which essentially means that what is out there in the superclass is not sufficient for me. I should have enough flexibility to go ahead and reuse it, or modify completely independent of it, provide my own implementation. Okay, so such things are there, and that is called as override inherited functionality. Now the example which I have taken here is, there is a person class, it has name and employee, and it has name and date of birth, and there is another subclass which inherits all the attributes of the person. They have the name, they have the date of birth, but apart from that they also have the employee ID, salary, and start date. Okay, now say for example, and I think we discussed in the last class also, not last class, I think the first class when we had Java session 1, that was, what if we don't have the person class at all? What we don't have the inheritance? What will happen? I mean, if you think, can't you code if inheritance is not there? Obviously you can, right? I mean, the only thing which comes in your way is name and date of birth. You have to put here. And there are a number of classes which extend person class, okay, then each thing has to be put here, okay. And maybe since you're just seeing person class with only two attributes, name and date of birth, you don't get the idea. But say if there are hundreds of attributes, and maybe functions, like where your Java file is running over 2000 lines, replicating it over and over again, right? And if you find a bug in that, then going and changing in all the classes which should have extended person, and then going ahead and modifying them, and then testing them. So that's a huge task. So it has actually increased your your work by n number of times. So n is the number of classes which should have extended the person. So the very idea behind inheritance is reusability, and that's what I want to emphasize. And when I say reusability, it doesn't mean that you just put all the reusable functions in one place and then extend it. They should logically belong together. Okay, employee is a person, is a relationship, is inheritance. Okay, it's not that you will put one common functionality and all the attributes in one place so that everyone can inherit it. That is not a good design. That is ridiculous. The relationship which exists is a, okay, employee is a person, right? Then it works fine. Okay, now say if you use a name and date of birth for representing a car, and date of birth being the date of manufacturing, if that is the case, can car extend person? No, but car is not a person. Even if the attributes there, you can reuse it. I mean, it's not the proper place to do it. Okay, so the is a relationship is inheritance. So like last time, let's go ahead to our WordPad. Hope all of you can see it. Okay, so is a relationship. Okay, this is the key. Person is a employee. Okay, so wherever you see is a relationship, right? Wherever you see this, that is a perfect case of inheritance. Okay, unless you have some your own constraints, right? Okay, so let's move ahead. Inheritance is declared using extends keyword, and that's what I've been telling number of times. So in the example which is discussed here, how will you put inheritance? Employee extends person, right? So this is how you inherit all the attributes. So this is how you tell in Java, okay, that employee class should extend or should inherit all the attributes from the person class. If interface is not defined, the class extends a class called object. Now, this is some advanced concept, and for 2 minutes, just hold on to your thinking from before, and think in this way. So every class, okay, in Java extends one class. So this is always true. This is a perfectly true statement. Okay. So there's one base class object. Okay, and this is a class from Java. And so again, I mean, there are class and there is an object of object, right? Because what is a class? Again, I mean, let's go back to the basics. What is a class? So as we discussed in earlier classes, class is a blueprint, right? What is an object? Object is the representation of this blueprint. So you can have multiple representations, right? So you can have multiple representations. Now, uh, okay, so now you can have multiple representations. Now, what Java has done is they have given you one class java.lang.object, and this is there in the JDK package itself. So this is one class written by Java folks. This is, you can say, it contains various metadata from the Java side. Okay, now all this metadata is out there, uh, and every class needs them, like to find what are all the methods, what is a class name, what is a class instance. All these methods are defined in object, and the way in which it has been designed is like, say if you write a class person, right, and this person doesn't extend anything by default. I mean, you do not define it. Okay, you just write person. So by default, the compiler makes this class extend object. Okay, so every class has to extend this class. So when you employee extends person, actually by way of compiler, this is inheriting everything from object class, right? So in this way, employee is also extending object and has access to all the objects, methods, and attributes. So ideally, there is no attribute inside it. The only thing which is inside it is uh, the only thing which is inside this is methods which are used. But the way in which it has been designed is that tomorrow, if something has to be put, if they can go ahead and modify the object class, uh, release an update, and then you again, instead of JDK 1.7, you download 1.8 or maybe 1.7.1, 1.7.3, 9, 4, whatever. So you get a release update, you use it, and they might have added some additional feature in it, and you get it. But that is a way to control and add features, but that has not been done till now. It has some of the basic methods, nothing more. Okay, but if there are memory requirements, if there's something else, they have kept a eye on this so that they can modify it. So you can say it's a way of controlling as well from the designer's perspective, if you think. So what are two data types? Now again, unless you go back and refer yourself again and again, it's going to be difficult. So what are the data types which we discussed? So the data types which we discussed was primitive data types. Okay, and I think we discussed this in the second class. And the second data type is reference data types, right? Primitive data types are some of the inbuilt ways in which we can refer to the data which we have to store, such as we have int, long, byte, short, character, boolean. Now, this is already defined by Java. If tomorrow they want to change this implementation, they can change it, right? You do not have direct access to how they have been implemented inside. Now, reference data types is used to refer to objects, right? And they basically refer to, in a code, they're basically referring to representation of classes. If you are referring to representation of classes, that is objects, I can modify it not at runtime for a different class, but at least if I find something and I want to modify it at the entire Java level, I can do it by modifying in the object class. So I think from the designer's perspective, it's a clever way to give you, first of all the metadata information, right? To put everything together in one place, right? And one more thing is to have a better control. If you are writing something and there are unforeseen circumstances, if tomorrow it changes, what to be done, right? So what needs to be done? So this thing controls it. Okay, so this is a way to do that. Now let's go back here. So now I think you will understand the statement, this particular statement. If inheritance is not defined, if that particular class is not explicitly extending any class, then by default it extends an object class. So there is a class java.lang.object, okay, and that is extended by default by whichever class is not extending any other class. And whichever class is extending any other class, like say for example here employee, that in because of default, okay, by default it extends all the attributes. So when I say default, I mean is this is a chain, right? You can say father, grandfather, grandson relationship. So you have like say employee, right? So you have employee, and employee extends person, and person by default extends object. Now person is having access to all the attributes of object, and employee is having access to all the attributes of person, which is basically all the attributes and functions which are defined in person class, plus all the attributes which are defined in the object class, right? So say here if you have such kind of relationships as CEO is another class. So in this case, again, CEO has access to all the attributes of object. How? Because person has access to all the attributes of object. Employee has access to all the attributes of person, and CEO has access to all the attributes of employee. So in turn, by default, it has access to all the attributes of object. Okay, and this is just for understanding. So you have just a clear picture. It's not that on day-to-day basis you're going to change this class. This class is not going to be touched by you. You're only going to use it. Okay. Now let's go below. So you have person class, your employee class, and that is what I've shown you. This is how you extend it, and this is in the last class when we discussed about classes and objects. That's using the new operator. You're creating an object that is actual representation of the blueprint. Okay. So each Java class has only one and only one superclass. So there are other languages such as C++. These languages support multiple inheritance. Okay, and for the reasons discussed in the last class, Java people did not go for multiple inheritance. They only wanted one class to be a super class for a particular class, and that's how it has been designed, and it's working perfectly fine till now. So I don't think that we are missing that feature that much. So each Java class has one and only one super class. That essentially means, and if we go back here, if we have like say employee, like say CEO extends employee, and maybe you want to extend, there is another class which is board, and since you is a board member, you just can't do it like this, okay, because this is wrong. One class can extend only one class, it can't extend two classes, so this is not valid, okay. So let's go below. So there is no limit to the number of subclasses a class can have. So that essentially means that say if you have say employee class, right? So a CEO class extends employee, and I mean let's not debate right now the usefulness of this class. You can say that CEO class might not be required. For I'm just giving it an example to help you understand the concept as such. Say for instance you have board members. So board members, maybe most of the board members, you have a rule in this company that they are that they should be employees. So in that case, they should extend employee. So if you can say there are multiple classes which can inherit employee, right? So that is what is meant. So one class, I mean this class, what is in the left, this the subclass, it can only extend one superclass, okay, but a superclass can be extended by many subclasses, okay. So CU extends employee, board members extends employee is possible, but CU extends employee comma board, that is two classes, not possible. This is wrong, okay. Now let's go here. This is what explained where there is no limit to the depth of the class tree is explaining. CEO extends employee, employee extends person. So this is absolutely fine. So you have classes, you have next level of classes, then you have next level of classes, and then you have next level of classes. So this kind of arrangement is fine. Okay. Now, even if this kind of arrangement is fine, I mean, if you keep on increasing it, the thing is that there's a lot of clutter. So in practical world, in practical enterprise applications world, where you go and code for enterprise applications, guys, please go on mute. Where you go on enterprise applications, just hold on. So where you go on enterprise applications, you actually have like one or maybe two, maximum three. The applications which I've used, they had only two layers, and but theoretically you can have 20, 30, 40, 50, whatever you want, those many layers. But with what scenarios we had till now, we never required that much. Okay, so let's move to the next one. At the very top of the inheritance tree is a class called object. That's what we discussed. Okay. Now, all Java classes inherit from object. The object class is defined in the java.lang package. So we have already discussed it. I think I should be pretty much clear. And this is what we discussed in the start of the class itself. That there are two forms of polymorphism. Okay. One form is method overloading, which we discussed in the last class. The second form is method overriding. That is essentially meaning that if you have two classes such as say person and employee, then then the person class will define one particular method, and employee class, the work is not sufficient by what it is defined there to do the job, and you override the method here, okay. So that is how it is. Now let's try to understand what it means, and I think all of you understand, but I just want to make sure I'm not missing on to anything. Say here if we go and if we have say a person class, right? So a person class, and let's go here. No, I think I can't write there. Yeah, Deshwara, please hold on for some time. Person, I think you should see to the videos as well which are there. Maybe H2K folks can help you. I can forward the links as well. In that case, you can say like up to date with the classes which have already happened. That can help you. So say person extends. Employee extends person, right? Now a person class like say has attributes which we discussed before, such as name and date of birth. And apart from mutator and accessor methods, okay, so now you will hear the terms mutator and accessor methods, which are nothing but saying that, remember, if you remember the first classes which we discussed, encapsulation. So encapsulation is nothing but hiding everything inside one class, encapsulating the data, right? So that other classes can't modify it. So in that we control the state and behavior of the object, so that there is one common place of modifying it, right? Now that is one basic principle of object-oriented programming. So from the class perspective, this will be marked in private, okay, this will be marked in private. So if this is marked in private, what does that mean? That means that it can't be accessed from any other class, even from the class which extends it, okay. So in that case, to get this data, you have to we have to do something, right? So mutator and accessor methods basically means defining the getter and the setter methods, which are essentially public in nature, okay, and that is you can access. So you have get name, set name, get dob, and set dob. So you have this much. Now after that, what else? Maybe say every person in one way or the other, you calculate working hours, okay, and maybe the way to calculate working hours algorithm here is daytime, right, minus, I mean, total time, which is 24 hours, minus sleeping time. This is how we calculate on an average person hours. And this is just an example to help you understand working better. So if you want to laugh about the example, you can go ahead and do that. But don't just get hung up on it. This is just to explain the concept about it. Okay. Now say if you come to employee class, right? If you come to employee class, it has various other attributes. Say EMP ID, then you have salary, then you have designation, and apart from that you also have mutator and accessor methods, okay, which essentially means get employee id, set employee id, get salary, set salary, get designation, and set designation. So these are not like essential, but this is the standard. That's how you write it if you want to give access to your private methods from the other classes, okay. Now coming back here, if you come here and see, now if you want to calculate working hours, now this is important because to get the salary you need to know the working hours for this particular employee. So you, whatever is provided here, that how many time a person is working, if you want to calculate on national level, you just see for how much time they're not sleeping, you just take an average and give it to the person who is requiring it. But not in the case of employee, right? But in employee, I mean, that is not the working hours. The definition itself is wrong. So the calculated working hours goes like this. You have to override it, okay. And here the definition is that may be like check on the leaves, okay, check on the office timings. So that's how you define uh, your algorithm, and then return the data back. So you needed this information, right? Because you had to extend it. I mean, that is required. So method had to be overridden. Why? Because whatever is out here, uh, calculate working hours. That is not sufficient, man. Why this is not sufficient? 24 minus sleeping time. That is not going to do the work for you, right? So what is going to do the work for you? You need to check on the leaves information, you need to check on the office timings, and then calculate the number of hours and then return that data. Now this is the working hours which you required in case of employee. Maybe for CO, if you go again, if you go in the case of CO, that information might not be relevant. Why? Because, I mean, check on office timings. He has to attend client meetings. For him, the office timing is irrelevant. Okay, maybe for him, working hours is from the home itself. So he has a different application to log it. Okay, so there are various things which you might have to consider. So again, if you go to the CO class, you again override this particular method. Okay, so that's how we do it. That is what is meant by method overriding. Subclasses inherit all methods from the superclass. Sometimes implementation of the method in the superclass does not provide the functionality required by the subclass. In these cases, the method must be overridden, and I think we have discussed these. To override a method, provide an implementation in the subclass. The methods in the subclass must have the exact same signature as the method it is overriding. Now, when I say exact same signature, again think from the perspective of method overloading. So, exact same signature means that the parameters which are there should match in the number of parameters and should match uh, in the type of the parameter, but the return type, etc., and say the access level, whether it is protected public, that you can change in the uh, superclass, sorry, in the subclass, so that can be done. Now let's go here. Okay, now if you go here and see banking account, right, so it has three attributes: owner's name, account number, balance, and you have deposit, withdraw functions. Apart from that, again you have mutator and accessor methods, which is discussing about get balance. Now you have another type of account, say overdraft account. Now it has extending bank account. So what that means? It means that it extends, or say in other words, it inherits all the attributes. So this one inherits all the attributes from yeah, it inherits all the attributes from the bank account class. And apart from that, whatever was the withdraw function here, okay, because overdraft means essentially means withdrawing more money from which is there in the account. Here, your withdraw function had a different implementation, and here they have a different implementation. Guys, please 1 minute. So overdraft account has it extends bank account, and you have provided a different implementation for withdraw. So this is a method overriding which I explained via my own method. Now this much is sufficient for understanding overriding, for understanding overriding and for understanding inheritance. Uh, okay. Now let's go to the final keyword. Now there's another keyword which we want to discuss here, which is final, and it has been clubbed with this session mostly because it has some relationship. It doesn't have explicit relationship, but it does have some rules with relation to inheritance. So if you think about the keyword final, okay, now what do you think when final is doing whatever is the name is suggesting? It just means that it's final, it can't be changed. Okay, now the final keyword can be used on three attributes. So say, in three types of, in three different places. So one is it can be used for, uh, it can be used on variables. Okay, it can be used on attributes, and it can be used on methods. So if it is used on methods, if you use final keyword, that essentially means you cannot override it. Okay, so if you go back to this particular PDF and go above, so if this withdraw function in the superclass, like here, we had defined one more keyword, final, public, final, void, then in that case you would not be able to extend it here. So this extension overdraft account was not possible. Okay. Now, what if the attribute is defined as final? Okay. So if the attribute is defined as final, I mean, if you define this limit as final, you have to initialize the value here. It will not leave you. I mean, but it will ask that it has to be initialized. So if you initialize it, that becomes a final value. So final values, once the value it has some value, that is a value which always remains. It never changes. So even if you try to change it, it's not going to change. So what that essentially means is, like say if I have a scenario like this, I have an attribute which is marked as a private final int a is equal to 10. Now if I do like this, not permissible, you'll get compile time error. Okay, why? Because this is defined as final, and if you do not do this, it is very much possible you can reassign the values. Final essentially means that the value has to remain the same. Once initialized, it's not going to change, it's always going to remain the same. That is what is meant by final here. Now again, attributes are nothing but variables, right? So this is what I meant by the third type was classes. Now you can also mark the classes as final. So you can go here and say that bank account is a final class. That's it. I don't want anything more. If that is the case, overdraft account which extends bank account, this is not possible. Compiler will throw error saying that final class cannot be extended. You're doing a wrong thing. Okay, so you can't extend a class which is final. Okay, so if you define final, cannot extend this class. Basically you cannot inherit this class. Let's talk in base terms. You cannot inherit this class. Okay, so this is how it's there for this one. Now coming back to whatever we have put here. So this keyword can be used in attributes, methods and classes. Methods can be qualified with the final modifiers. Such methods cannot be overridden. That's what we discussed. Classes can be qualified with the final modifier. Such classes cannot be extended. So this is one final class. And Java also has used such features. So remember we were discussing about string class, right? And there is an assignment as well on this. So string class is defined as a final class. You cannot extend it and define your own features. You cannot extend it. Okay. So similarly, you can also have requirements in a class where whatever you have defined that remains fixed. Okay, that does not change. And if that is the case, I mean, if you cannot change, you cannot change. I mean, that is a requirement of the project. That is how you designed it. Okay. Now let's move ahead. Super Java keyword. Now again, so what does the super keyword means? The super keyword is basically referring to the super class. It is as simple as that. Okay, so the super keyword refers to the super class of the class in which the keyword is used. Super as a standalone statement represents a call to constructor of the super class. So if you see this particular example which we have defined here, right? You see the example which we have defined here, like say my class string argument, you have put as super arg. So what that essentially means is that if any class was extending this call would have gone there. Okay. Now super.other string method. That essentially means that if my class extends some other class, it will call the method of that particular class. Okay. Now, super.method name represents a call to a method of the superclass. Super as a standalone statement represents a call to a constructor of the superclass, which is defined out here. Okay, so let's stop for a moment. We'll try to see in practical terms what this means. But for today, what I've done was that since it's not getting so many assignment questions, I have put the questions here and it is up for discussion. Like we'll see what it stands for and then see the output. Okay. So here what we have done is that we have defined a class A1. Okay, there is one method, there is one attribute here, integer I, and there is a constructor A1 where you have the value of I as 5. Now once you come to B1, B1 extends A1 and it has another attribute I, and don't get confused. B1 has its own copy of I, A1 has its own copy of I. Okay, now if you come here, B1 has a constructor. It takes two parameters, A and B. So first of all, they're calling the super class. Okay. Now what they're doing is super.I is equal to A. So whatever is the value here, I mean for this one, I, they're setting the value. So by default, once you called super, the value of I was initialized to 5. Now see if you would have defined this value, defined this attribute as final, I mean this was the case. I mean it was done. Once you had initialized I as 5, there is no way of changing it. But it is possible here because we have not defined it as final. Okay. Now coming back here, if I is equal to B, so now when if you see here, since we're in this class, when you refer to I, you're referring to the attribute I or this particular class B1. But to refer to the attribute I of A1 class, we have to put it as super dot I. Okay, super dot I is setting the value for whatever you are passing in A, you are assigning that value to the attribute I of class A, and whatever you are passing in B, you are assigning that attribute to attribute I of class B1. Okay, now there is one method which is defined show. So So what this method does is it prints a value of I from the superclass and subclass, right? Now say if I define a main method and put the values there. So I define a b1 class, b1 b is equal to new b1 10 12, and I call b dot show. So what should have happened? I mean, we are passing two attributes here, 10 and 12, right? So if you're passing 10 and 12, now since the way in which you have done is you are defining a constructor here, you see b1 b is equal to new b1 10 12. So you're defining constructor here. So you have 10 and 12. So what will you get called? This will get called, right? So once this gets called, you have a super call. So that essentially sets the value of the attribute I of even class is 5. Okay. So what has happened till now? Till now, for a dot I value has been set to 5. Now coming back. Now what is the next line? The next line says super dot I is equal to A. Now what are the values which we have passed here? The constructor call was 10 and 12. So A has a value 10. So super dot I, what that means? That is for which is a super. So super is a way to refer to the super class, which is here A1. So here the only attribute I was there, which initially we had set to 5, but now we can set it back to 10. Okay, because that's the instruction which has been given to us. So we'll change it. In which scenario was this not possible? If we had marked this attribute I as final. So once you give a value to it, it cannot be changed. That's how it is. But here that is not the case, so we are able to assign it. Now what is the next statement? I is equal to b. So we are passing two parameters to this constructor, 10 and 12. So when the value of b was 12, I is equal to 12. So that means that the value of attribute b, and we'll write it as b dot I just to avoid confusion, is 12. Okay, so this is what we have done till now. Now let's go below and see. And when you say show, what it does, it prints the value I in superclass and the I in subclass. So what will the value of I in superclass? So the superclass is A1 here, right? Now A1 has a value of 10, okay, and a subclass has a value of 12. So that is what it is going to print, okay. So output of this program is 10 and 12. Okay. So that is how we need to do it. Now let's go back to the second one. Now the next one which we have is we have defined a final class. Okay. Now this final class we have defined one final attribute and we have defined one final method. Okay. Now there is another class which is there which is extending A. We have overridden the method AINC. We have put the value as A is equal to something. Okay, and then from the final underscore demo class we are trying to create an instance of bb, and then we are calling the method AINC. What is going to happen? Okay, now if you think, first of all the thing is, let's go back here. So b1 b1 is equal to new bb. Okay, fine. b1 dot AINC, ideally you should have called this, printed the value, but before doing that you have to see from the compiler perspective, because compiler is going to look into it and see what should have been done. So when the compiler looks into it, it says, uh, like if I come here and see, the class is defined as final. I mean, this is a final class, and if the class is final, it cannot be extended. That's a use of the keyword final. So that is the case. If bb extends a, this is wrong. This is not possible. So you get a compile time error because of this. So even if you solve it, like say you remove the final from here. Now AINC, this method you're trying to override. Now compiler sees that you're trying to override this method, and this method is final. You cannot override it, but you're doing that here. So compiler gives you again an error message that this is final. You cannot override it. You have to go back and remove the final. Okay. So there are two things which you need to do. After that, it should be fine. After that, it should work fine, and we can like run it and see. So this is what we had for final keyword, super keyword, and method overriding. So super keyword we discussed. So again, I mean it's a sort of recap. So what did super keyword do? So super keyword is basically a way to refer to a super class. Okay. Now you can either refer to the constructor or you can refer to the actual method. So it's a short form to refer to the super class. Now, if you use final, that is a way to stop inheritance, to stop overriding, stop like reinitializing the value. Final keyword is to say that the value is final; it cannot be modified further. So that is what is meant by final. And this is the two things. Then the third thing was overriding. So whenever you have inheritance, you can define your own representation for the methods, and that comes inside method overriding. Okay. Now, what is inheritance? So this is inheritance is basically extending or inheriting all the attributes from the superclass and defining your own set of attributes, or like whatever the set of attributes there, you can override it. Not the attributes but the methods, you can override it and define your own implementation for it. Okay, so this is what is all about inheritance. And you should always try to draw parallelism from the earlier classes, just to see how everything fits together in your mind and how you're able to understand everything. So whenever you hear such concepts such as inheritance, polymorphism, try to relate it with the actual implementation. Okay, so you have encapsulation, which is essentially a class. Now I'm referring to the basic pillars of object-oriented programming which we discussed. Abstraction, encapsulation. Encapsulation is basically referring to a class. Abstraction is abstracting the data in one place. That was like via methods, via classes, and all those things. Then you have inheritance, which we have discussed right now. Then you have polymorphism, which had method overriding and method overloading. Okay, so this is how you have to draw the parallelism, right? Now, I don't know whether I can, but let me see. It's not spend the time. We'll go here. Okay, just trying to whatever we discussed. We'll write one class and see how all this works. Just so that you're clear from the practical perspective as well. Okay, but meanwhile, if you have any questions, I can take it. So unmute yourself and then let's discuss. Yeah, guys, any questions?
Yeah, can you, how do we get these notes and everything?
Uh, what is your name?
So sorry?
What is your name?
Uh, so sorry, I didn't hear you.
No,
I didn't
no.
understand you.
I was asking what is your name and what is your email address?
Oh, my name is Rajesh. Yeah.
So I think you have copied that email chain, but what is your, yeah, email ID?
Yeah, it's RAJ.
Can you ping me that in WebEx? The thing is that
Yeah, yeah, I'll just,
I have a email chain which is going on. So after the class, and last time it was late. So after the class, I already go back and reply to that email chain, and in that way, all the people of this class get the material. At the same time, I also ask H2K folks to send it over to their students. I'm not sure they have done it or not, but that's how the protocol had to be. So, what I'll request everyone in this class is that you have my email ID, right? I'll just write it over here. What you should do is
what is your email ID?
just a second. You can see my screen, right?
Yeah.
So my email ID is abhishek.h2kinfosys at gmail.com. So I'll request all of the people who are there on the call to drop me an email, okay, just a test email with the subject line including, okay. And once I have this email, I'll form one common like sort of group in my local, and I'll always forward all the materials to that particular group. So if you do that, that will be really helpful. This goes for all the
I'll,
people out
I'm
there.
doing it right now.
Sorry?
Hi, Abhishek.
Yeah.
Abhishek, I have a question. This is Akila.
Tell me.
Like last week, for the last session assignment, I had a hard time writing a program for the roll numbers. I didn't know how to display the details of the students based on the roll number. Can you show a sample program as to how it has to be done? And I was also not sure how to get 20 inputs from the user, because it says 20 engineering students, and we have to get the input 20 times and display it based on the roll number, right? So, can you just show me how to do that?
See, so how do you get input from a program? Like, like say if I have to write interactive program, how do you get that input?
Yeah, how to get input from the user for 20 times, and how to display the information based on the roll number.
My program is starting, so I think this is how the format, the format of main method is. Now this args is something which is the argument list. Okay. Now this argument list is something which you can pass at runtime. So whatever you pass out here actually gets stored. I mean that is what is comes here, and this way you can take 10, 20 or whatever inputs you want from the user. Okay, so this is your gateway. I'm just trying to do that. I don't know why it's taking some time.
So, can I use integer, or I should use only string? If it's like
It accepts
if it's like numbers, then roll number, it's like a number, right? Can I use string for roll number to get the input?
the thing is that the only attributes which you can pass using this main method are string. Okay. Now
Oh,
say
okay.
the way in which you have to refer is to every attribute you can refer using the this is an array, right? Array of strings. So you can refer it using args0, uh, args1, and let's do one thing. Let's stop the recording.